In this video, we'll look at question 78 from the 2016 exam. So this question, we have a plank of non-uniform density, so its center of mass is not in the middle, which is used to make a seesaw pivoted in the geometric center of the plank, but not in the center of mass, which is offset by a distance x. On one side, 1.2 meters away from the pivot, we have a boy of mass 35 kilograms. And on the other side, a distance 0.8 meters, is a woman which weighs 60 kilos. And given that the system is now balanced, we're supposed to find x and the force between the plank and the pivot. And if we say it's all balanced, all in equilibrium, so can you think what kind of balance it is? What physical quantities has to be balanced? It is the torque. And the magnitude of the torque is defined as the force times distance, where the two have to be perpendicular. In our case, it must be that the total torque acting downwards, or in this direction, on the left-hand side has to be equal to the total torque on the right-hand side. And that can now be written as an equation, or as the force times the corresponding distance for every 3 terms. And this is now a linear equation in x, which allows us to express x as just positive 0.4 meters. So the center of mass is on the right-hand side of the pivot, and it's 0.4 meters away from it. And the total force between the plank and the pivot, well, we can use Newton's third law for that. We have one force acting downwards, second force, and third force acting downwards. We know the magnitude of these: 600, 150, 350. And this is the downwards force which the pivot will have to balance with the sum of all these three. So the force will be just 600 plus 150 plus 350, and that gives us 1100 newtons for the force between the plank and the pivot. So these two results in the exam were option H.